Hello, I'm Bobby DeVoe, working with UK Cloud. I'm here to tell you how you can scale with Docker Swarm using Packer, Terraform, and OpenStack. I've put the link, just a link to my talk. So if you think it's really good or rubbish, if you could just leave some feedback, that'd be awesome. Thanks. About me. Just a quick one about this, because I don't have long. I created my first website when I was 9, which is in 1995, which makes me feel really, really old. I've been doing a lot of PHP dev, but more recently I've taken to the DevOps world. As you can see there, I love Docker and Terraform and Golang. What I've not put on there is that I'm a bit of an Apple whore, which is why I'm doing the slides with my watch. So why am I here? Why am I here? Why am I here? Let's have a look. I'm here to spread awareness of UK Cloud and OpenStack. Basically, UK Cloud have their own cloud-native infrastructure, which is running OpenStack. I want you to see how awesome Docker Swarm is. I want you to love Terraform, which, to be honest, I hope all of you do already, anyway. And I want to show you how to scale an app using all of the above. A quick one about UK Cloud. I've got to do that for Tim. So UK Cloud is a public sector. It's not a public sector company. They've got lots of public sector clients, including the HMRC, NHS, Bank of England. There's circa all these partners. You've probably used many websites that are hosted within UK Cloud, such as anyone doing their self-assessment things. Obviously, one of the reasons why the slide's up here just so happens that UK Cloud are recruiting. So if you're looking for a job, there you go. Why OpenStack? So I'm talking about Docker Swarm on OpenStack. Obviously, UK Cloud have got cloud-native infrastructure, and it's OpenStack. But also, if you want to use Docker Swarm on AWS, you can already use Docker for AWS, and Docker have already got a similar one out, Docker for Azure. And they all have CloudFormation templates or the equivalent for Azure. And obviously, if you want to do something similar in OpenStack, you need, well, there isn't anything out there, so you have to use what I've done. So. Because I don't have long, what I'm going to do my final demo, which is normally at the end, but I don't know if I'm going to have time. So I'm going to do it now to show you how awesome it is, and then I'll explain how to do it and see how much time I've got. So, boom, boom, boom. I might have to put this down. Basically, if I just quickly log into our cloud-native infrastructure, this is very similar interfaces you might imagine from any cloud provider. It's showing you what instances you've got, how much RAM, floating IPs you're using. As you can see, I don't have any instances running whatsoever. Basically, this is just an overview of what's running. I do have here a Terraform plan, which is going to show you everything that it's going to do. Obviously, I've got lots of slides explaining what all this is, but I just want to show you the demo first. So basically, this is going to create 20 things. If I just say, what also I'll head over to the network topology in cloud native infrastructure, because it's really good at showing you what you've got. Right now, here, we've just got the internet. We don't have any instances or anything. I'm just going to Terraform apply. And if we go here, it's really cool, and it'll show you everything popping up as if by magic. Fingers crossed it works. So there we go, still got the internet. Whoop, there we go. We've got things appearing. We've got a network, and we've got a swarm manager firing up. So obviously, we can't create any more managers for the Docker Swarm, and we can't create any slaves until this is fired up. So this is still in the build phase. It's just powering up. It is pretty quick, but as you can see, the Terraform apply is running in the background. It should fire up, and whoop, there we go. Lots of nice, if you look at all these are Swarm Slave 4, Swarm Slave 2, Swarm Slave 7. I've created lots of Swarm Slaves just to prove that it works. So this is busy doing pretty stuff. And it finished. It created 20 things, which is what it said it was going to do. And if we go over to overview, you can see that we've got 13 instances, security groups, and we're using a floating IP. So straight away, we've seen how awesome Terraform is. We use Terraform, and suddenly we have lots of instances running a swarm of it's actually a PHP application. We've got one server, which is here, it's the swarm manager on an IP address. If I go to this IP here, fingers crossed, there you go, I've made it really big. This is just a simple PHP API returning some JSON. As you can see, this is the code that I compiled early this morning sometime. What I want to show you is how awesome the scaling is in Docker Swarm by the fact that we've got 13 instances, and because it's Docker Swarm, it's got auto scaling built in. It'll literally just do a round robin between all the instances. So if you look at the host name variable there, which is obviously just a generic, randomly generated thing by Docker, if I just refresh this page, it's changing. So this is me just refreshing the page, and literally out the box with Docker Swarm, you've got auto scaling, just going through all those 13 instances. That's what I think is really cool, that you can just do straight out of the box. So that's kind of the live demo, which is normally at the end. So now I'll kind of explain how you can do all that and how you can make that work. So I'll go back to this thing. There we go. Cool. So hands up time. Who's using Docker yet in production? Oh, actually, is that my next one? Okay. Up and down, up and down. Who's using Swarm in production? Not many. Terraform? That's kind of what I expected. I thought most people would be using that. Packer? Cool. Who's actually not got any of those yet and would love to? So a few hands, awesome. So this is the prettiest picture I could find of a swarm. It looks scary, but actually Docker Swarm's not that scary. So if you're familiar with Docker, I've actually cut out some slides because of time constraints. But we've already, thanks to Cameron, covered what Docker and Docker Compose do. So Swarm is actually, as of Docker 1.12 and Docker 1.13, Docker Swarm is baked into Docker natively, and it's just called Swarm mode. And it gives you lots of things which I've copied off their website. The main things that I think are awesome are the service discovery and load balancing. In that demo that I just did, I showed you the load balancing in the fact that as soon as you fire up these and they're talking to each other, it literally just, it'll go through in a round robin fashion and go to each of those. But the big win of Docker Swarm is service discovery. Since using Docker Swarm in my examples, I've not actually found a need for console for the service discovery element, simply because you literally can just look up by host name. So if you, from any of those nodes, you say ping nginx, it'll just, it knows where that is, and it'll pick any of the containers running on any of the instances. So it's pretty awesome like that. If you want to set it up locally on your Mac, which I've got a little demo that I can do again, let me just skip, see if I've got it on there. Yeah, I'll do that now. So straight away you can see localhost, there's nothing running, which is a good thing. So now if I go to, I've got a Docker Compose file. Docker Compose. If you can see this, again, this is based on the assumption you know what Docker Compose is. I'm actually using version 3. Version 3 is the one which allows you to deploy a stack directly from Docker Compose or from a Docker Compose file. So similar to Cameron's example earlier where you saw he was creating several Docker instances, here we've got a PHP FPM instance and the build directory where the Docker file is. in addition to the image where we want to save it. The ports, environment variables, I've got in there just prod for now. But we've also got this deploy section, which is all part of the new Docker Swarm stuff. So you can say that we want it to be replicated, how many replicas. So we can say we want 3, 5, 10, whatever. That's at the initial creation. And we've also got things such as rollout delays. So when you update your application from a rollout point of view, you can say, well, I've got 10 servers. I want you to do one, wait 10 seconds, roll out another one. So it's got the rolling update built into it as well. So, and because we can do that all locally, that's what I'll do now. Docker, so Docker stack deploy, and then pass it in the Docker compose file. And that will file it up. And the best command to see what's running, Docker service ls. You can see that we've got one web. I've called it web. It's actually Nginx. We can call it Nginx if you want. And PHP FPM. If I now go back to my local host, you can see that it's running that application. There we go. So that's running locally. And similar to what you may have seen earlier, you can Docker service scale web equals 10. There you go, I can type. So look, if I go Docker service ls now, you can see that that is slowly just bringing up more replicas. So now I've got 10 Nginx containers. So that's how easy it is just to scale. Obviously, this is it's not auto-scaling the infrastructure. This is auto-scaling the containers, which is why we need to use something such as Terraform to actually build out our infrastructure, which is what my demo did earlier. Because if I refresh this page, although I've got 10 containers, it's still on the same host. And as you would probably agree, scaling on one instance is a bit pointless, which is why you need to scale everything else out. Fail. So this is the old way that you could do it. You could do Docker service create. This is before Docker 1.13, where you could build it into the Docker compose file. I've kind of skipped through that. That's the Docker service scale that you can do. This is the Docker compose file I've already shown you. So I won't get you to ask any questions just yet. I'm gonna get through a bit more. So how do we scale on some real infrastructure? It's okay saying that I can scale on a Mac, but again, it's just on one host. What we need to use, we need to use Packer to build our images, Terraform to build the infrastructure, and Docker Swarm to deploy onto that infrastructure. And again, Jenkins is on there. A question that I asked last time I did this talk said, like, who's using Jenkins? And I know a lot of you are using it. What I would ask is suggestions on something better, because I think it's shit, but everyone uses it, and I can't find an alternative. So, what is Terraform? What is Terraform? You already know what Terraform is, so I'm not going to cover that. Quick deployments. This is awesome because Cameron covered some of this as well. So basically, these are open questions. Basically, how long do your builds take? What's acceptable? Quick is relative and depends on your requirements. What I'm talking about there is Cameron, ITV, 40 minutes. To them, that's quick. That's amazing because they cut it down from 4 hours. It's literally, it's relative to your own individual needs. But that's kind of what I'm talking about in the sense of foundation images. And what I'm kind of covering here to deploy my Docker Swarm is building some base images to allow us, when we commit our code, we don't want to have to rebuild the whole infrastructure, because again, that'd take forever. So basically, we've got nightly builds running of our images, and then when you want to deploy code, literally all that does, it has to run the tests and deploy it on the pre-baked images, which run nightly. Kind of, I think Ansible and Puppet and Chef, a lot of things like that, have encouraged people to have systems where you get a base image, then you run your Ansible scripts. But I've worked at so many places where you're waiting half an hour for Ansible to run just to deploy some code, and I just think that's a bit stupid. I think a lot of people are building foundation images now, but if you're not, you should definitely look at doing that. With Packer, which I know some of you guys are using already, you can provision your image using Ansible and deploy it into either Amazon as an AMI or into OpenStack Glance repository, or even as a Docker container in Docker Hub or key.io or whatever your thing is. Packer, you know what Packer is, obviously build in. You can take a basebox image such as CentOS, apply things over it using your favorite provisioning tool. I have an example here. This is actually an AWS example. I should probably change that to an OpenStack one. Hey-ho. So here we have just our Ansible playbooks running. If you've not used Packer yet, I would definitely recommend looking at how to use it, because it is literally so simple. Even if you've got Ansible playbooks already, you can just plug those into Packer and basically take a base box, run your playbook over that, and then that can basically run nightly and build your image, save you having to run it each time you deploy some code. So obviously, we've got Packer, we've got Terraform, and we've got Docker Swarm. Kind of now I want to put it all together. What I did is build a little bash script which loops over my containers. I've got a PHP FPM container and an Nginx container, and then I'm basically just building the container and pushing that out to Docker Hub, and that'll basically go out every night. So we've got an Nginx repo which has got everything that we need on it, and it's got our PHP container with everything that we need. What you shouldn't do, though, in your Jenkins is put your password in there, because what I did, I actually created this as a blog post first, and someone kindly emailed me and said, you know that you've put your password in your blog post. Thankfully, he did tell me, and I learned something. What I learned is that when you do Docker login, it will create a Docker config JSON wherever you type that command, and then you can put that on your Jenkins server, so you don't have to put your plain text password for someone else. So I've commented that out now for nostalgic reasons. So yeah, don't do that. If you're running your parameterized build report, you can see each of your containers running. I've got a few others in there. PHP FPM, I've got console in there just for testing reasons. So then you've got your PHP image, which literally copies the code from its repository onto the container itself. It doesn't have to do anything else because we're already pulling in the base image. We've got the PHP FPM latest build. That's literally already got all the environment variables. It's got everything we need. All we need to do is copy the code and run composer install. And then we've got when someone merges a pull request into the master branch, literally run Docker Compose build and basically run these commands just so that we can build our container with the code on and push that code up. So it's called dummy app PHP. That's pushing it up to Docker Hub. And then here, where's my little pen? In red, anyway, this stuff in red. This is basically saying Docker service update. So imagine you've got your Docker Swarm manager running up there. You're basically just SSHing to it and basically saying Docker service update with my new image that I've just built. And as you saw in that Docker Compose file, I put a rolling update of 10 seconds. So to roll out our new app on 13 instances, that will basically take whatever 13 times 10 is in seconds. So there you go, about 2 minutes. It will roll out, and you can put a rollback thing on that if it fails. So infrastructure. It's okay having our scaling Docker Swarm, but what we want to do is scale our infrastructure. So here, what I'm going to do is show you how Terraform is working. First, we spin up the Docker Swarm manager. And literally the exciting bit here is when that first manager comes up, it does Docker Swarm in it, and it says Docker Swarm join token. That basically just outputs the token for any other nodes to join, and we're just putting that in the home directory and then saying Docker stack deploy, that exact same command you saw me type on my Mac earlier. And then on any other swarm managers, so secondary masters, if you like, this can be any number of them. You might have an extra 2, but I tend to just have 1 master and then 2 extra masters. All it does is SSH to the first master, copy the join token from there, and then it literally just does Docker Swarm join and then token, and it passes in the token that it just copied from that first master. So then straight away you've got 3 Docker Swarm managers running in a nice little cluster. And then all you need to do is add some workers, which literally works in the exact same way. This is just a Terraform template. You can put in the node count. So my node count, I actually said I wanted 10 workers plus the 3 masters. I've hard-coded that because I know I'm always going to have 3 Docker managers. And this is literally just the same. It's copying the key over from the master and then saying Docker Swarm join. And it's passing in the worker token. So it knows it will join as a worker. And that will literally, as soon as these Docker workers come online, it will join the swarm. What we've got here is a little bit of a hack, Docker service update. In Docker 1.13 there's a new command, force. That's just to redistribute, because if you're going up and down with your Docker swarm, you may have an issue where you've got too many containers across, and force kind of just spreads it all across again, until there's a better way to do that. And here is where there's my little config file where you can put in either 1 or 5, or I've actually got it set to 10 nodes. So you can basically grow your infrastructure using Terraform, and by using the cloud init stuff in Terraform and in cloud native infrastructure, which is part of OpenStack, you can grow your Docker Swarm elastically as well, along with your infrastructure. And that's about it, really. There you have it. Provisioned Docker containers, infrastructure as code, all automated deployments. It's all scalable, and it's all available to do on OpenStack and UK Cloud.